Okay, so next one. What are the biological functions of DNA polymerase 1 and 3? What is the biological function of DNA polymerase 1? They will be cut the Okazaki sequence segments. What is the DNA polymerase 3? Polymerization. And what else? Proofreading. What is Okazaki segments? That's a small sequence in the lagging band initiated with an RNA primer. Is that right? So then they will be connected, but then finally they have to cut. That's Okazaki segments, fragments. You can use your own language to describe that. Okay, this is a question is important. This is a nuclear sequence of fragment of double-stranded DNA from E. coli. Then the initial places is A. The first thing, where are going to be the promoter? How are you going to label the promoter? And I just said, this question is very important. Related to these slides, this is the key. It's +1, -10, and -35. So what are here? This whole, sorry, how can I do it? This area, this bracket should be there. Okay. This is a promoter. Okay, you should label both. And the 5' to 3', 3' to 5', you should label both. Show the promoter. That's a promoter. Name the enzyme recognized promoter sequence. What is that? RNA polymerase. We just said RNA polymerase. Name the protein subunits. Allows the enzyme identified in the question 40 to recognize sigma factor there. Write down the mRNA transcription label from 5' to 3' end. Are you going to label everything? Lots of people will do from beginning to the end. No. Where they started. You need to find the what? You need to find the AUG. So, this is started. When this question, a couple of years ago, around 10 years ago in the exam, everybody is to write it. You don't have to do it, because it doesn't start it. They started from AUG, so where are they? You only need to write this part. Is that correct? How you write it? It's exactly the same as the top. The only difference is T become U. So you can start to write here. I'll just give an example. You can start to write like here. Okay, the first is A, then U, then G, then A, then U, then C, then the same. G, 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 C, G, A, G, A, C. And then you do, this will be 5 prime, sorry, 5 prime, and this will be 3 prime. This is too large, so we'll make it small. Make it small. See? That's the answer. Okay, maybe a little bit small. 8. That's good. 8.5. That makes sense. See? That's the answer. So that's the answer right here. Okay. Second translated code. What amino acid is this? AUC. What is AUC? Well, then you have to go back to see the codon. What is AUC? What is ILU? Isoleucine. That's AUC. Good. That's a question. It's very comprehensive, but I think this is a good review question. You should mark here. Because this question tells you, per motor, tells you DNA RNA polymerase, tests you sigma factor, tests you how to write the sequence of the mRNA, and tell you about the amino acid 3 codon system. And you don't forget about here, you have AGG, what is this? That's Shai-Dagano sequence. AGG, recognized by the 16S RNA and the 30S subunits inside of the ribosome. So this is something you have to be careful about that, okay? Could this RNA transcript become an mRNA? Why or why not? Yes, because they have AGG. And AUG is right here, see? Stop codon. If you deletion of the marked G1 have any consequences? Of course, because when you delete it, the AUG is gone. There's no more AUG. So the start codon will be deframed, we could say. What will be the consequence of deleting the lowercase right here? Based on the sequence above, well, this is an open question. It could be yes or no because it depends downstream. It depends the mutation where they happened. If it's scientific mutation, then it's not going to affect anything. If it's the mutation happened in the position 1 and 2, then will be create a different of the amino acid sequence. Okay. Question number 45. You don't have to worry about this. This is just let you think a little bit. 43, 44 will be a good question you should know. Because this is test to you, the AGG with the Shai-Dagano sequence, and AUG is an initial code. So I think this questions 3 and 4, and also the short answer, this is important because this is a key sector of the DNA replication, transcription, translation. That's why I said that this review question is very valuable for you to study. Okay, last segments. This is not difficult. This one is just for warm-up, which means we go back to see anything, we miss something. Coenzyme. They are small molecules derived from vitamins. Yeah, let's go come from the vitamins. Sulfur, laminate, antibiotics, functional. This is we already mentioned. This is C. Transferring electron by dehydrogenase, we already mentioned, it's called fermentation. When I designed this questionnaire, is you already finished 1 and 2. Then you have this section is for review. It's for review by yourself. So that's why there are some questions are repeated. The purple sulfur and the green sulfur bacteria obtain energy from growth under anaerobic conditions. Wow, this one is reduced to SO4 become hydrogen sulfide. What is the best definition of fermentation? We'll talk about already. Oxidation of carbohydrate with organic molecules serving as a final electron acceptor. Okay, this guy. Disulfur vibro. We already called the disulfur vibro. So what is their terminal electron acceptor? Is that right? We already talked about this. Is disulfur vibro. This is a little bit difficult question because they go back to test you. This means it's a genome name. And this means it's a morphology, which is a vibro. So this is a bacteria based on the genome name. You already know the morphology and how they do the mechanic. How they do catabolism, because they're using sulfide as an energy resource instead of glucose. It's a sulfur bacteria. And the black deposit. Remember SIMA test, the sulfide is black. Because there's a metabolic ingredient that they can use. So, this is the answer is H2S. Okay. You don't have to worry about this one. This is all the time using it's electron farm. It's a mud, then you drop it in the bubbling. its best answer is methyl fermentation. But they will generate a little bit of carbon dioxide. So this A and C both are fine. But it's just for fun. I mean, let you know they will have those type of the experiment that can comes out. But I won't test you because it's only for fermentation part. Outside of the bacterial cell, remove electron and proton from organic molecules by dehydrogenase. So this is C. This is D. This is another question, which is paraphrase chemosmosis. So you should mark here, this question is related to chemosmosis. Then combine to the question in the previous question, the field blank, these you can study them together. What is the best definition? Oxidation of carbon oxide, inorganic molecule, excluding oxygen, serve as a final electron acceptor. So this definition, in the practice exam, at least I have 4 questions tested. So when you write this on your notebook, you're going to be connected with those 4 tested questions. That's why these are questions for you to review to study. Okay, because they're connected with each other. Phosphoenolpyruvate to pyruvate gases, the conversion. Release carbon dioxide, involve conversion ADP to ADP, yes. Involve substrate level phosphorylation, so B and C. Not to release carbon dioxide. This is well confusing you because TCA cycle, alpha ketoglutarate become succinate CaOA, there is a carbon dioxide release. This is a carbon dioxide release. This is just confusing you, okay? So you don't have to worry about this. How does fermentation of glucose different from the oxidation of glucose? That's the same thing. Fermentation anaerobic, oxidase is aerobic. Fermentation produces less than the oxidase does, so B is correct. Pathway when the oxidase by the respiration. So I think this is this will be ABC. How are the aerobic respiration and anaerobic respiration similar? Well, they use inorganic molecule as terminal electron acceptor. The primary purpose of catabolism, and we barely mention, we talk about the metabolism is anabolism and the catabolism. So what is catabolism? It's generate ATP, is that right? They generate ATP. It's catabolism. Anabolism is biosynthesis. They're going to have to use ATP. Or which one? Oh, this is tough. Then you have to go back. This is a tough question, so we're going to go back to see right here which one. I can tell you the answer here. This is why I shouldn't delete it. This should be bigota. This is another sulfur bacteria. Okay, one term of Krebs cycle. How many NADH? 1, 2, 3, 4. And 1 FAD become FADH2. So which is the best answer? 3 NADH, 1 FADH2, and this 1 substrate level phosphorylation. You should not include this guy because it's transition step. So 1, 2, 3, 1, 1. Okay, 3, 1, 1. This one not encoding transition step. I don't talk about the chlorophyll. That's a carbon-carbon cycle. You don't have to worry. You don't have to worry about that one. These you don't have to worry. I didn't talk right now. That's ABC. Okay, that's all. So what are the strategies to study? Number 1, go over all the questions. Pay much attention to the segments of 1 and 2. Go back to read your slides connected with those. I will upload a video onto the eCampus when we talk about side chain of amino acids because I don't have time to do that. But I'll upload onto the eCampus. The side chain of amino acids, okay? That's another set of the extra points. If you still need a review, Carly will be there tonight, 8 o'clock in the lab room.